Hi everyone, today we are going to be doing Cambridge IGCSE Additional Mathematics 0606 Paper 1-2 for February-March 2025 series. This is the first paper for the AdMath syllabus to be using the 2025 to 2027 syllabus, which includes the new topic of circle coordinate geometry, as you can see in the formula list here, as well as the first paper of the exam does not allow a calculator. So there will be the two new things that they have implemented this series onwards. So actually the intended audience for this video is for those who are taking the exam in the May-June series for 2025. So I will not be going through very in detail each topic, why we are doing each step. I assume that this is for last revision for those who are taking the exam soon, and not going to go through each step lah. And I assume that you have those basics quite good already. It will be just as a last revision. So for those who wish to have a more detailed step, maybe you can let me know. Then I can make some more video like this. Right, so let's get straight into it. For question 1, it's about a modulus graph, right? So we recall that a modulus graph is a V-shape and it does not go below the x-axis, so because it's always positive. So the only thing we need to find is about the x-intercept and also the y-intercept. Right, so let's deal with this first one. For the y equals 4x minus 1, first we want to find the y-intercept. So we set x to be 0. Right, so here will be getting a positive 4. Inside here is a negative, but the modular sign will make it a positive. So our y-intercept for this will be 0, 4. And to find the x-intercept, it will be setting y equals to 0. So then we're moving there, getting x to be equals to positive 1, right? Positive 1. So obviously when you're doing this on your exam, use a ruler. But for now, I'm just going to sketch using as straight as possible freehand, right? So here will be a positive 1 and here will be a 4, right? So next we're looking at the other modulus graph. For here, again, setting for y-intercept, we set x equals to 0, so y will be equal to y will be equals to 2, and then for x-intercept, we will have setting y equals to 0. Right, so x will be negative 2 over 3. Right, so and we can see that the gradient here is 3, which will be compared to the gradient of 4 is less steep. So let's try to sketch it to be looking like that. Right, so like that. And our y-intercept here, as we have found, here will be 2, here will be negative 2 over 3. Right, then one more step is to label the graph. Right, here we'll label 3x plus 2, here we label y equals to 4, x minus 1. Right, and as you can see that it has two intersection points, which will be useful information for part B of the question. Okay, so for question B, we're going to solve it algebraically first. There's two different methods of doing this. The first method I'll show you is to split it into the two cases where you equate one as positive, one to the positive value of the modulus, and one to the negative value of the modulus. Negative 3x plus 2. Right, so we rearrange this, you're getting 6, and then here x will be equals to 2 over 7. Okay, right, so this is the first method you can do it. The second method you can do it is by squaring the entire both sides, right? So we square one side and we also square the other side. So this removes the entire case of the negative. So I mean this includes both cases of positive and negative also. Just you might make a little bit more mistakes when you expand the equation, right? So alright, so we have this quadratic inequality here, and actually if you looking at this one, we can tell that we want it less than 0, so it will be this between these two values. So whatever the roots is, the x will fall in between the roots, right? So we can try to factor this to find the critical value first. I think we can able to factor, right? So here will be -6, here will be a -2 lah. No, no, the other way around. Okay. Okay, so x either will be 6 or x equals to 2 over 7. Right, so you can see we reached the two critical values similarly with the previous method also. So from this, you just need to figure out what is the final inequality. So as I said, from this quadratic inequality, we can do x is in between these two values. But if you're just doing the first method, you're getting the two critical value, you can actually refer to the graph depending on whether you're drawing the graph accurately lah, right? So here will be 6 and here will be 2 over 7. So we want to see where this 3x plus 2 graph is above, right, more than the 4x minus 1 graph. So maybe I'll highlight this 3x plus 2 in red color. So this is the graph that we're looking at, and this is the region where it is on top of the other graph, right, for x minus 1. So between these two values of x, it satisfies this inequality. So again, we reach to the same conclusion that this will be the final answer. Right, so this is for question B. Moving on to question 2, you can see it's a trigonometry question that includes a graph being shown. So we probably want to find the A, B, and C values. Okay, so A is amplitude, B will be the frequency, and C will be the center line, right? So hopefully we can try and count first for C. C will be a center line, which we can just add these two values and divide by 2. So C, 3 minus 7 over 2, we get -2. So we try to sketch that first on the graph. A 3 minus 7, -2, yeah. Try and sketch this center line on the graph. So we draw a dotted line to indicate that this is the center line to make it easier, clearer for us. Alright, so from the center line, you can see that, right, -2 I label here. You can see from the top to bottom, top to the center line is 4 units. Also here is 4 units. So A will be just writing down the value of 4. Okay, next will be B, which is the frequency, right? B, you can think of it as how many times the graph will one complete graph will occur within the 360 degrees or 2 pi radian, or you can just try and use this formula, right? 360 divided by the what's you call it, the period, which is t, right? So that's will be the period in this case. It's not so clear lah, but as you can take how many graphs within here. So from here there's 1 cycle, here to here there's 2 cycle, here to here there's 3 cycle. 3 cycle within 360, that will be instantly we know that it will be 3, right? So this graph will be 4 cosine 3x minus 2, right? That will be the graph. Okay, next is a coordinate geometry question. Point A has this coordinate, point B has this coordinate, and given that the line AB is the diameter of a circle, find the equation of the circle. So maybe we can try and sketch it first. So draw the Cartesian plane xy. Right, so -3 will be somewhere around here. That's A. B7 -8 around here lah. Let's see. Doesn't have to be accurate, it's just a sketch. So this is the diameter of a circle. The center will lie here and the circle will be like that. Okay. So first we want to find two important things for the circle. Right, we look at I'll write down the circle equation here for your reference. So two important things you need to know is where is the center of a circle, right? For the center AB, and also what is the radius of a circle, right? So that's the two important things we need to know. And we know that the two coordinates here for A and B, so we can definitely find the center easily by using the midpoint, right? Midpoint. So midpoint, I just need to add the two coordinates together and take the average. So -3 plus 7 over 2, 6 minus 8 over 2. 2 and -2, right? Sorry, -1. Okay, I'm not using calculator because this paper also not allowed to use calculator. I will try not to use calculator together also. Okay, so that's the midpoint. We know now that here is 2, -1. And of course, I mean, it's not represented so accurately in this sketch because I did not draw to scale. But let's imagine that it is in the fourth quadrant here. Okay, so now we want to find the radius, and we can do that by using the Pythagoras theorem, right? So you can use either point A or point B. It doesn't really matter because they are the same distance anyway. From the center to the circumference, that will be the radius. Okay, so using the Pythagoras, we have x, then minus the x value. I'll use point B lah. Alright, -1 minus -8 square root. Okay, so again, without using calculator, I try to calculate this is 25 add together with 7, 49, 5 and 7. Right, so 74. Okay, we can just leave it like this first. So because when we sub it into the circle equation, we have to square it anyway. So let's put all this information into the circle equation. So remember, even when you find the midpoint, when you put it back into the equation, it will be a negative value, right? So here, if here is positive, make it a negative value. So x minus 2 squared, and since our y coordinate is a negative, we make it into a positive value into the circle equation. And now r squared will just be simply 74. So this will be the final answer for the circle equation, right? Find the equation of the circle. Okay, question 4. Given the polynomial p given by this value expression, and a is a positive integer. So a is a positive integer, we must try and write this down first. A is greater than 0, and it's given that this is a factor of px. So this is a factor of px means p half will be equals to 0 according to the factor theorem. Okay, so I believe, okay, since there's only one unknown variable and one equation, we're able to solve this easily. So we just need to sub in the 1 over 2 in all these x, right? So a squared okay, so we have come to here where this a cancel out. A squared will be 16. Right, so a squared 16, a will be the plus minus of 4. But since it's specified in the question where a is a positive integer, we will ignore the negative, right? So a equals to 4 positive only, right? Okay. Hence factorize px. Okay. So we know our a value already, so let's just rewrite the px in its full expression. So 4 squared 16, and then 8x squared, 4x plus 2. Okay, so we already know that, I mean, we are given one factor in the question, so we can try and use that to our advantage by doing the long division first. Right, so first value I'm going to put up here will be 8x squared. So 8x squared multiply this, I get 16x cubed, 8x squared. So here once I divide this, I will end up with 0. I can take down both of these values. So here we'll add the 0x, and for the constant value, I will just add a 2. Okay. So yep, this is fully factorized, and px will be 2x plus 1, 8x squared plus 2. Okay. I don't think this is able to be factorized even more. Right. Hence show that this has only one real root. Okay. So given we know that this is a factor already, this is definitely having a real root, because when we equate to 0, x has a value. But for this one, this root, or I mean this factor, we are unable to do. I mean, there's a few different ways to do this. Either you can show that x squared is a negative value, or you can even if you use this b squared minus 4ac, right, you get, what's b value here, 0, right? So 0, 4, 8, 2. So you end up with a positive value. I mean negative value, sorry. So negative, therefore no real roots, right? So this is the two different way of proving it. As long as you make your justification clear using b squared minus 4ac, or you saying this x has no real solution. And then you should also say, I think you should also mention to be safe, that 2x plus 1 is the only factor which has real roots, right? So for 1 mark, right? Okay. So completing the square form for question 5 is a quadratic equation. They want you to complete the square. Okay. So okay, I want this into this form. 2x squared minus 2x plus 3. So let me first, for completing the square, we want the coefficient of the x squared to be just 1. So I'll factorize out the 2 first from both the x terms. I'll just leave the 3 by itself because it's not affected by this one. So this one, I want to write it as a complete square. To do so, I want to know what square will yield this one, right? X squared minus x, which I know from the b coefficient, I just need to take the half of that, right? And I square it, it will become x squared minus x plus 1 over 4. Right? So this part here is what I want. Right? Oh my god. This part here is what I want to represent in terms of this. Okay? So I'll rearrange it to make it into that. Okay, so once I have this expression, I can take it and put it back into here and replace it. So 2x squared plus 2x plus 3, 2x minus half squared minus a quarter plus 3. And finally, I'll expand this bracket. And here we'll have 5 over 2, right? Okay, so that's the completing the square form. Okay, and why we're doing this, it directly leads us to the next question, where we need to use this result to proceed to do this function interpretation of a function, right? We want to find the greatest value of p for which f has an inverse. So just a quick recap on what type of function has an inverse is only a one-to-one function has an inverse. And since we know that quadratic expressions are not one-to-one, and therefore they do not have an inverse. But if we restrict a quadratic function at its let's say at its minimum point or at its symmetry line, and we ignore one half of the graph. Now it is a one-to-one function where it has unique input to map to unique output. So therefore it has right inverse function now. And which is convenient because the previous question we have already put it in the completing the square form, which we can take these two values as our x and y coordinate, right? So this will be our x coordinate, this will be our y coordinate. We just have to remember to make this to become a positive, right? So whatever value here, we take the negative of as the x coordinate, right? So this point here, the minimum point for this graph will be half and 5/2. And in this case, we're looking for the domain only. So we just concerned about the x value. So for greatest value of p, f has an inverse is half, right? And using this value of p, find the range of f. Now for the range, now we are looking at the y value. So this quadratic is a smiley face. The coefficient of x squared is positive, so it will have a minimum point, and all the values of f will be greater than the minimum point, right? So f will be greater or equal to 5/2. Right? That will be the range. And using this value of p, find an expression for f inverse. Right. So since we have already expressed our quadratic equation in the completing the square form, we will use that to find the inverse. So I will first rewrite the function, and for inverse we swap the variables. Okay, so x and y we swap them, and using that we find we rearrange to get y back as a subject, half, right? So at this point now we have a square to deal with, and when we bring this, or when we try and get rid of this square, we'll have a positive negative situation on this side. So how do we know which square root to take? Either the positive or the negative is depending on our domain, as described over here already. X has to be smaller than p. Okay, so I have sketched this wrongly, and we're actually ignoring, right, because we want, right, this is our domain. This is the only allowable function or values of x. So we are ignoring the right side of the graph, right? And so when we do our inverse, how the graph will look like is it will look like this, right? It will be going downwards because I reflect it in the y equals to x line. So with this behavior that we know the graph is decreasing for inverse f. Now we know, since it's decreasing, we take the negative square root, okay? And we can solve this now, right? Half minus the negative square root, okay? So if it were the case that we were going to take the domain for x greater than p, and we are only looking at this side of the graph, right? So let's say this p lah, okay? And we know that when we reflect it on the symmetry line, the graph will be increasing. Okay, the graph will increase, and we take the positive square root. Right? This is the positive square root, and this one will be the negative square root. Okay. Given that tangent is this value, and between these two, this will be the quadrant 3 and 4. Find the value of cosine theta. Okay, so let's try and draw what this looks like. ASTC, right? We have 4 quadrant, and we are only existing in these 2 quadrant. And for this particular ratio, it's positive. So it can only exist in the third quadrant. I mean, it should be able to exist in the first and third quadrant, but since it's specified that theta is in only the third and fourth quadrants, we are only looking at this one. Okay, so tangent is opposite adjacent. We will take opposite adjacent like that, and this one will be theta. Okay, so for cosine theta, we are going to look at the adjacent and hypotenuse. Okay, so we have the two sides of the right angle triangle. We are able to find the hypotenuse easily by using Pythagoras. Okay, so square root 5 squared plus 5 squared. So we end up with square root of 30. Okay, so I'm just going to leave it as that first, and we can write it cosine theta adjacent. We take 5 and then over square root 30. So that will be our value. Okay, for sine theta, similarly, we're going to take the opposite over the hypotenuse. So the opposite is square root 5. Square root 5. And then hypotenuse, that will be the square root 30. Okay, you can just leave your values like that. Since the question did not specify a specific form you should give your answer in. So you can just leave your answer in this form. Does not need to be rationalized. Okay, next find find this value of secant and cotangent theta. And now they specify the form that they want, right? In this form where there's a square root 5 at the bottom. So secant theta and cotangent theta, I'll just rewrite that first. Secant, looking at the third letter, that will be cos, so there will be 1 over cosine. Third letter of cotangent, that's a t, so there will be 1 over tangent. Okay, so take the reciprocals of each of these, and 1 over cosine, we get square root 30 over 5. 1 over tangent, we get 5 over square root 5. Okay, now we try to make this together. And the bottom, remember, we need the square root 5. So let's combine these two first. So I need to cross multiply. Here, since they are both under the square root, I can multiply them together. Here, I will just need to multiply 5 with 5, that's 25. Then at the bottom, I have a 5 square root 5. Okay. 30 times 5, I believe I'm able to get 150. And 150, I can actually factorize 25 times 6. That will be 150. And why I'm taking the 25 is so that I can take it out of the square root and make it into 5 square root 6, 25, 5 square root 5. And now I can get rid of all the common factor of 5, and it will turn into this. Right, and I believe, okay, we have, yep, so our A in this case, that's 25, B will be 1, and C is 6. Okay. Okay, question 7 is looks like an integration question. This shows part of the curve, this curve, and this line intersecting at point A. So first we want to find the coordinate of point A, which is just equating them. So I will equate these two. Right, this gives me a quadratic equation, which I believe should be able to be factorized. So yep, this will be the correct factorized version, and we will have two values of x. So how we know which value of x to take is according to the graph here. We know that here is the origin point, so this point A lies along the first quadrant, and the value of x will be positive. So we're going to reject this negative 2. And don't forget, okay, they want the coordinates of point A. So we also need to find the y coordinate. That I just sub into the y formula. Right. So that will be 4. So A will be 3 over 2, 4. That's your final answer. Okay, now they want to find the exact area of the shaded region. This exact area. So let's try and plan out the integration we want to do here. So it goes from 0 all the way to a, and we have known that a will be, I mean the x coordinate of a, it will be 3 over 2. And okay, so at this point, the line on top, there will be this hyperbolic or curve line. So I'm going to take this, the integral of this minus of the integral of this. Okay, integral from 0 to 1.5 of the curve, and take away the this one, 2x plus 1 and dx. Okay, so after simplifying, I should be able to get. Okay, so this first part of the integration of the integrand, I'll be able to get a 5 ln x plus 1. Here I'm getting x squared and x. Okay, so this is a definite integral. I don't need to include the arbitrary constant. I just need to sub in the values of 1.5 and 0. Okay, so 1.5, 5 ln half 9 over 4, 3 over 2, and taking away the 0 be, okay, so 5 ln 1 and the rest is 0. So ln 1 we also know that it's a 0, so this also goes away. All I'm left with is this thing. I can simplify a bit, 5 ln half, and this one I can simplify to become negative 3 over 4. Okay, so yeah, we don't need to simplify this any further because this is already in exact form, and it does not specify again what type of form we should leave it in. So this is fine. Okay. Equation 8 is about series and sums. Okay. So a first term of a geometric progression is 10. Let me just write it down. U1 is 10. For geometric, I will use a U, and this geometric progression has a positive common ratio of R. So R is positive. And arithmetic progression also has first term of 10. Okay, so for arithmetic, I'll use a T1. So this will also be equals to A lah. Okay, A. And as a negative common difference, D. Okay, so let me just circle the information. The second term of the geometric progression is the same as the fourth term. So U2 will be equals to T4. The third term of the geometric progression is the same as the sixth term. So U3 will be T6. Okay, so remember for a geometric series, this will be the term-to-term rule, and for arithmetic series, this will be the n-term formula, n minus 1 d plus a. Okay, so we just try and use this, put it in the, put in the values, right? So r, okay, so a actually we know the value, so 10. We just straight away use 10. T4 3d plus 10. Okay, I will just leave that there for now. We'll deal with the other one. 10r squared 5d plus 10. So I believe we're okay. Let's try and eliminate some variables here. I think the easiest way to do that, I will rearrange these both equations. So I'll do this on one side. I'll do this on the other side also. So it's r minus 1. Okay, r minus 1. Here also r squared minus 1. 5d. Right, so I'll label this equation 1 and equation 2. I can take one divide by the other. I'm left with this one. Okay, so far, and we can cross multiply this, and now we are left with a quadratic equation in terms of r, which should be factorable. So -1, -2, right? So r either will be this or this. Okay, so I think both of them, they fit the, right, they're both positive, so we don't know which one to take yet. So I'll just leave them both be, and we will use one of this equation, right? We will use maybe equation 1 for r is this, and we'll sub the values in to see what's the value of d, right? So d will be 10/3, 2/3 minus 1, so -10/9. Okay, so this is indeed negative, so this will probably be the solution, but let's check for the case where r is 1. So d will be 10/3, 1 minus 1. Alright, so this one definitely will be 0, and this is, we'll reject this solution. Okay, we'll reject this solution. So this will be the only right pair of answers. Okay, so just maybe highlight them in red. Okay, so yeah, that's our solution. And okay, determine whether the geometric progression has a sum to infinity. So remember, for the, I believe it's also included in the formula sheet if you do not remember, right? So yeah, so the geometric series here, there is a condition. For sum to infinity, the modulus of r has to be less than 1. So if we come down here, we come back to here, the modulus of, right, 2/3 is indeed less than 1. So just say less than 1. Therefore, the sum to infinity exists for this progression. Okay, maybe, yep, we do it like this so that it's more specific. The modulus of the 2/3 is less than 1. Okay, next is a logarithm question. Okay, so we have two logs with two different bases, and we want to solve for x. So either you can change the base to 2, or you can change the base to x plus 1. It doesn't matter. So I'll probably change this base to 2. Okay, so remember the change base formula. Log AB same as log CB log log CA, right? So this one I want to change it to a log 2. So I want to change the log 2. Okay, and so since log 2 base 2, there will be just 1. I'm left with 1 over log x plus 1 base 2. And this 4 I can just multiply in. Okay, I will multiply both sides with the log, so to get rid of the log in the base. So I'll multiply this, and what I'm left with is a log squared, and 2 log x plus 1 base 2. And remember that this does not mean you can bring the power in front, right? So this means is a log multiplied with a log. So for the power rule, which you can bring the power in front, that square has to be inside the argument of the logarithm. This one you can bring in front to the multiple. But for the power applying to the entire logarithm, that is the power rule does not apply there. So we have to treat this as a quadratic equation in terms of log. So I'll rearrange it. Okay, we rearrange it like this, and I should be able to factorize it. I copied wrong the question here. 3, 3, should be 3, this should be a 3. Right, so a -4 and a +1. That works. So we have this situation. We have this situation. So to get rid of the log, we will I mean, we'll raise both sides to power 2. So we're left with x plus 1 on this side and 2 power 4. Here we're left with x plus 1 and 2 power negative 1. So here we can write as negative 1.5. Here we can write as 15. So this will be our two solutions to x. And you can try and back the domain to see whether this fits or not. Because here, this value of x, wait, sorry, yeah, I did do this wrong. This should be a negative half, right? Negative half. So actually both of these are acceptable. Both of these are acceptable answers. So this will be both two solutions to the same equation. But sometimes do be careful when you get the final answer to this type of question. You should try and see back to the original equation whether if you put back into the function, if you get a negative value in the logarithm, means that that solution must be rejected, because as we know that the argument or the domain of the logarithm must be positive and greater than 0. So be mindful of that. Right, point P lies on this curve and the x-coordinate of P is 5. The normal to the curve at P intersects this line at point Q. Point R is the reflection of Q in the tangent to the curve at P. So let me try and sketch this situation out. The Cartesian plane. We have a curve. I'm not sure what this curve looks like. So I'm just going to simply sketch it. So let's say this is this curve. Again, I do not know what this curve looks like. It's just a sketch. And then also we have this line. X plus y is 11. And where this... Right, so the normal to the curve at P, let's say this is P, the normal to this curve, I will draw that using different color. The normal, right, so let's say, okay, I'll draw a tangent in green first. So tangent at this point P, okay, let's say this is a tangent, and the normal, try and draw it like that, and this is the normal, intersects this line at point Q. So let's say that this is point Q. Point R is the reflection of Q in the tangent to the curve at P. So what's useful here is that we know that the normal and the tangent, they are perpendicular to each other already. So we can directly take the distance of this and double it so that we know this is R. It lies on the same line. Okay, so we want to find R, alright? So it's a 9-mark question. So let's try and slowly do this. So first we want to find the normal, right? The equation of the normal. And okay, maybe we try and find P first, right? So P is to be 5, and if I put in the value here, okay, 5 plus 2, 2 over 3, 9, 5, 9. Okay. The normal to the curve at P, right? So let's find the gradient, and the gradient will be dy dx. So bring the power down, multiply by the derivative of the inside function, that's the chain rule, and take away 1 from the power, that's the power rule. So maybe I simplify this a bit. Okay, and we want to find the gradient at P, so we just sub in the value of 5. That will be 10 over 9. Alright, okay. Again, try not to use the calculator here. Try and do your mental arithmetic, because try to train yourself to have no calculator for paper 1. Okay, so this is our gradient for the tangent. For the normal line, we know that the gradient will be 1 over the gradient of the tangent. So we'll take the reciprocal and make it negative. Okay, so right, this is our gradient of the normal line, and it will intersect through the point P, so that we are able to find our C or y-intercept value through P 5 9. Okay, so C value will be positive 27 over 2. Okay, so this one will be the value of our normal line. Okay, so with this we can try and find our point Q by equating it to this line here. Or maybe, okay, if we rearrange this 11 minus x. Okay, so we equate this to 11 minus x. So x will be negative 25. Okay, so that's the first, that's the first point of our point Q. Second point, the y coordinate of point Q will be 11 minus 25. Sorry, minus negative 25. Double negative will be positive, so 35. This value is not 35, it's 36. I made the wrong calculation here. Double negative becomes 11 adding 25, that's 36. Okay, so here is 36. Okay, now that we found point Q already, by symmetry we are able to get point R, because we know that we just need to follow how many units to move down, how many units to move right. We just have to follow the same procedure to get to R. Okay, so we need to know, okay, here is 5 9, that's our point P. Okay, here is point P. So moving downwards will be 31 units downwards, not mistaken. Sorry, not 31, 27, right? 27 units downwards. So I'll leave it as a negative 27. How many units to the right? That will be 30 units to the right. So all we need to do again is add 30 to the x coordinate and take away 27 from the y coordinate. Okay, so point P, not point P, point R, right? Point R. From the point P 5, I will add 30 to the x coordinate. Then I will also take away, what was the value? Negative 27. Take away 27. So point R will be 35 and negative 18. Okay, so that will be the final answer for point R by symmetry. Okay, so for this type of question, you should be sketching all this information out, try and represent it graphically so that you are able to visualize it and it's easier for you to solve it, rather than just relying on algebraic methods. Okay. Okay, vector question for question 11. This diagram OA is A. Okay, so I'm just write it down. OB is B. And M is the midpoint. Okay. Point N is ON is 3 and A. The lines BN and AM intersect at the point X. Okay, so find OX in terms of A, B, and lambda. So OX will be this line. So let me see what type of paths we can take to go there. We can take OA to AX. Okay, that's a possibility. So we need in terms of lambda, so we need to relate bx into the equation somewhere. So maybe we can go from OB to bx. Okay, so OX Okay, put OB adding together with BX. Okay, so BX, okay, first of all, BX, how do we write it? Okay, BX we can also rewrite it as lambda multiplied by BN. Okay, and BN we can write it as BO and ON. BO and ON. Okay, ON we know that is, okay, since we know this, and also it follows that ON will be 3/4 of OA, which is 3/4 of A, right? Okay, so BO we also know that it's a negative B, so everything will be in terms of AB and lambda from this point. So OB, that is B, lambda, negative B, and 3/4 of A. Okay, so just write this, clean it up a bit. 3 lambda, right? So this is OX, okay, in terms of AB and lambda. So for part B, now we want to find OX in terms of AB and mu. So mu we need to relate this one, MX. So I'll erase this. We want to relate MX. Okay, so we can write OX as OM together with MX, and then MX as a mu MA. Okay, so MA, how do we do that? MA will be going from OM to, sorry, from M to O and O to A. Okay, so we can do that. So MA, I rewrite it as MO plus OA. And we know OM, okay, M is the midpoint of OB, so it will be half of B, right? And OA will be just A. So we have all the information we have here. So half B, mu negative half B, and A. So again, mu A plus half minus mu half B. Okay, so now we have two expressions for OX, okay, and two unknowns, lambda and mu, which they are both scalar. Okay, I think we are able to solve for lambda and mu now. Okay, so OX will be equal to, first I'll write in terms of mu, then I'll write in terms of lambda. Okay, so for vectors, we can equate, right, in their respective unit vector direction. So we actually can equate, right, in the A unit vectors, mu can equate it to 3/4 of lambda, and in the B unit vector, you can write it as 1/2 mu half equals to 1 minus lambda. Okay, so now we can substitute this into here. Alright, lambda will be 4/5. And now, finally, mu we can solve also, 3/5. Okay, right, so this will be our final answer. I will highlight it in red. Okay, so 4/5 and 3/5. Okay, I think last question. Okay, it's a differentiation question together with reverse differentiation question. Okay, so for this type, we have a product here of two functions, so x and an exponential. Okay, so let's do the differentiation. First, maybe we leave x and we differentiate the exponential. So using the chain rule, I'll differentiate the top, so that's 3, and we leave the exponential. That's the first term. And now we differentiate the x. There's just 1. I will not write it and leave the exponential term. So simplify it a bit. Okay, so this will be our final answer. Okay, hence find the integral of this. Okay, so for this type of question, we need to recognize what's inside the integrand and what we have. I mean, from the result that we have differentiated, we need to find the similarity and try to make it into this integrand here. So what we can notice is the integrand as well as this entire thing, okay, this entire thing and this one is similar. What's missing or what's extra here is only this 3. Alright, this coefficient in front. So we want to try and get rid of that and make it the subject. Okay, so I'll rewrite the entire result that we got from part A. Okay, so now we try and isolate this one. Okay, we rearrange it. And now we want to get rid of the 3, so I'll just divide both sides by 3. Okay, so 1/3 of this. Okay. Now, if you notice that on our left hand side of the equation, we get exactly what we have in the integrand here. So I can go ahead and integrate both sides of the equation in terms of x. Okay. And I mean, on the left hand side, I will just leave it because that's what we want to find. And on the right hand side, what we can do here is we can separate the integrals. So addition and subtraction for integrals, we can separate them. And the constant, we can take out the constant coefficients. And okay, so we'll deal with the first integral first. We integrate the derivative of this. So remember that integration and differentiation, they are just the opposite of each other. They are the inverse of each other. So if we have an integration and a differentiation, they just both cancel out. So we're just left with whatever is the argument in the operator, which will be this one. And remember to multiply back by the constant. Okay. Okay, for the next part, integrating an exponential function, that will be just remaining the same, except we have to by the derivative of the inside function. So divided by 3, end up with 1/9, and the exponential is the same. Okay, so that will be your integral of, on the left hand side, that's what the value will be, and don't forget to add a plus c because this is an indefinite integral. Okay, so that's the end of the paper. Thanks and good luck for your exam.